Peter Rowlett from Sheffield Hallam University. I have the pleasure of working with him. He's a reader in higher education maths, teaching and learning, and he's going to talk to us about teaching an introductory programming module for maths undergraduates online. He's going to focus on a second year elective mathematics module, how it worked last year and how it's going to work in the coming year. So I shall hand over to him.
Okay, thank you. Hi. Hopefully you can see that and hear that. Yes, I have a title that says exactly that. I thought it was a good idea to sort of say, here's what I did last time, here's what I would be doing, you know, here's what happened in lockdown in March, and here's what I'm planning to do when the students return next week, which is when we start teaching again. Oh, before I start, if you don't mind, a little plug. If you're interested in programming, teaching programming, Matt Jones and I edited a special issue of MSOR Connections earlier this year on programming in the undergraduate mathematics curriculum. So you might be interested in that. It's full of case studies, basically, of people doing that sort of teaching. Right, so my module. It's called Programming with Mathematical Applications. It's an optional second year 20 credit module. They take 120 credits in a year, so this is 20 of them. It's year long. 2021, this coming academic year, will be my third time teaching the module. The number of students varies. I've put between 12 and 27 because I think that's accurate. There are 12 in this coming year. There were 20 odd last year and 20 odd the year before. We just have a smaller cohort this year, so it's a smaller group choosing my option. The learning outcomes are that they will select and use appropriate programming techniques to solve mathematical problems in various contexts and develop, test and implement a substantial project of some sort. So in semester one, I do sort of Python based programming fundamentals as if they've never programmed before. Now they've all done a little bit in VBA in the first year. VBA is the programming language within Excel. And they have done that for 4 or 5 weeks before Christmas, and then the following September they come to me and they've largely forgotten it. That said, there are a bunch of them who've been programming for a decade and who already know all, you know, you get a whole range, don't you? But the baseline has to be assumed as being they didn't know any programming, they did a little bit in the first year, and they have since more or less forgotten it. So we do programming from scratch, then we do a bit of Excel and graphics stuff. In the second semester, some web databases, and then an individual project. I'll talk a bit more about each of those. So the fundamentals, my idea is to teach programming from scratch, but potentially in a new language, because they've sort of done, it's like, here's what you did in VBA last year, but we're going to do it in Python. It's also to emphasize the mathematical aspects, because this is a maths degree, this is not a computer science module. I try and talk to students about programming versus coding. So programming being the sort of logical, you know, putting together an algorithm using programming constructs to encode an algorithm in a way that a computer can understand it, rather than coding, by which I mean, you know, writing code in a particular language. I sort of don't care what language this is in. I'm using Python, but I don't consider that to be essential. And it also sort of lays the foundations for the rest of the module, as I'll talk about. Because I'm quite keen on this business that they're learning to program and that supports their sort of mathematical logical thinking, I do a bit of teaching at the start that specifically isn't coding. In previous years, I've made a little sort of gimmicky prop that I start the class, the first class, by not letting them get the computers out and doing some logic work, basically. So reminding them about some propositional logic and so on. And this exercise where I get them to write down an algorithm for something like putting on a t-shirt or making a cup of tea or something like that, and then they have to read their neighbors and try and willfully misunderstand the algorithm, and trying to get them to think about, you know, writing precisely, encoding precise instructions and that sort of thing. I use Python. I think it's fairly well used. It's quite a nice language. I wasn't particularly familiar with it before I started teaching this module, but it seems grand. I like that it's the VBA bit that they do in the first year, the students do in the first year. There is so much sort of extra cognitive load to get to start with VBA, because you have to have that you open Excel, and then behind Excel is a programming language, but to output anything you either have to stick it in a cell in the spreadsheet, or you have to make a pop-up box appear, and etc. Whereas in Python you just type print hello and it prints hello, you know. So it's very clear to be able to teach these very simple programming basics without having all that extra stuff layered on top. I'm aware that Python does some absolutely fab things, but I try and focus my teaching on the fundamentals that are common with other languages. So, you know, loops and if statements and things like that. And there's this sort of Pythonic way of doing things that I think is fine, but I'd rather be teaching them something that could perfectly well be a different language. If they need to know a different language, they can sort of swap out for another one. So this is my list of topics beyond the mathematical bit at the start: variables, if statements, strings, loops, so on, functions, recursion, a bit of error handling and input and output and things like that towards the end. So that's my kind of first roughly 8 weeks of content. So we go quite slowly through this. They do exercises and things like that. I'll talk a bit more about that later. And then we have a little section where they do some Python in practice. So I try and give them some prompts to get them to do something a little bit more, you know, a slightly larger program where they have to think a bit more about how they're going to program this, how they're going to encode this algorithm really. So this is things like, you know, take in a matrix and spit out its eigenvalues, or you know, simulate a coin flipping 1,000 times, or whatever. There's a whole list here, so that they have to have a go through and try and think about doing something a little bit more complicated than the earlier exercises, which have been, you know, generate the first 10 Fibonacci numbers with a loop or whatever, or with a recursion or something like that. Then we move on the last few weeks before Christmas. We do a little bit of Excel and graphics. There's an Excel VBA refresher, which basically says, here's what you've just learned in Python, and then here's a reminder of how that worked in VBA. I'm very keen on this idea that you sort of show students that what they've learned is they've learned how to program, and the coding in a particular language is sort of additional to that. So that if they find themselves in a job where they're using an unfamiliar language, that doesn't necessarily matter. They've got this firm starting point. I remember I used to teach somewhere where all the computational stuff was MATLAB, and I would have final year project students with me who think that a for loop is a MATLAB thing because they've just not experienced it in any other context. So they do some exercises. They do an Euler's method. They do some data import and analysis. What I quite like about Excel at this point, apart from the fact that it's just something different to show them that programming works elsewhere, is that it gets very quickly to all the graphical stuff, so you can have user interfaces and things like this. And then last week before Christmas, we do a little bit of LaTeX ticks graphics stuff. So why Excel? I mean, I don't have a lot of experience with it, but I understand it to be used. There are a lot of anecdotes in the department of students going off on placement and doing fab things, because basically everybody has Excel, and all companies, but they don't all know how to use it, that sort of thing. It's useful. It's also used elsewhere on the course. And as I've said, it's got this graphical interface stuff without having to worry about how to get into all that. It's sort of drag and droppy. Why LaTeX and ticks? I think it's fun to see programming in an unusual context. So we do some drawing a pretty picture by programming writing a little program to draw this picture or something. And again, I think it's just fun to say, like, you know, I haven't taught you this language, but the skills you have apply here. So here we go, sort of thing. Then after Christmas, we do a bit of web and databases, HTML, CSS, MathJax, generating all that from a program, in this case from Python, since they know it, and it reminds them that they know Python because it's now a few weeks since we've done it, and a little bit of SQL queries, just very basic stuff. Why SQL? I think it's well used. It's a good idea for them to be familiar with these days, I think. HTML, CSS, MathJax, I think ditto. I mean, this is the future of modern mathematical communication, right? So I think it's good for them to be aware of how all that works. The classes, this is where I was quite interested listening to the first talk, but I do very minimal direct delivery because I think this is learning by doing. And I think that there is a very limited amount that can be learned by watching me do programming. And I've had this experience before where I'll do something on the board and then some students will try and copy it and they make mistakes because they've got syntax errors left, right and center. I've had students call me over before saying, look, we've all done the same thing and this one works and those two don't. And you look at it and they've got brackets in the wrong place or something like this, because it's about doing it and getting used to that requirement that you write in this very precise way. And just watching me and going, oh yes, well, I basically understand that is only going to get you so far, I think. And also I have a very small class in contrast to the first talk today. So this year I'm only going to have a dozen, usually about 20 or something like that. Well, that's, I can go around and talk to them all within a session, you know. And so students work on their own programs from notes that I've written, and I just drift around. It's quite hard to teach this way, actually. It sounds quite I'm just going to let them get on with it. I've written the notes once, that's it, I'm done. But it's really hard not to keep you want to just say, oh, just move that to there, and then you know, trying to ask the probing questions and get them to an understanding by themselves is quite hard. So I answer questions when they ask them. I give formative feedback on work as I see it going around the room. And that's what I do in the class, basically. The assessment is, they have a first coursework, which is really tightly specified low level. It says, write me a function that if I give you a number, you'll give me the square root of that number back, or whatever it is. Really tightly specified, just check that you've got the basics, 20%. Then I have a slightly more elaborate program that they have to write. But they've got it's not got that low level. I'm not describing it in terms of write a loop that does this and then write a thing. You know, I'm telling them what I want the program to do. So they've got a bit more flexibility and a bit more higher level skills involved with that one for 30%. And then the second half of the assessment is an individual project. I'm going to talk a little bit more about that just because it comes relevant in a moment. They have 6 weeks at the end of the year with 12 hours of in-class time because we have 2 hours a week. They have a choice of topics from a big long list of topics that I've written, most of which are fairly vague even within themselves. So it'll say, you know, here's what the iterative prisoner's dilemma is, please investigate it, or something like this. And what they're supposed to hand in is a program, and I don't specify a language, and a HTML page which explains, first of all, the technical content in whatever form that is, mathematical, statistical, or computational, whatever, how their program actually works, how it implements the technical thing they're writing about, and a critical review of the work, which is really important, and most of them do it in the 5 minutes before they hand it in because they don't really think about it, and that's the thing that I'm trying to encourage, right? We also, as we go along, have 2 in-class progress meetings. So that they meet with me in the second week, tell me what project they've chosen, we scope it out a little bit, they tell me about their initial plans and so forth. And then in week 5, we have another little chat, how are they getting on? And try and help them to land the plane, because at that point sometimes the topic has completely blown up in their face and they've got a million threads open and they don't know where to go, and trying to get them to something that they could hand in, and also to remind them that they're not just writing a program, because some of them get very into writing a program, but they're also supposed to be making this little report, so remind them that that needs doing. So that seemed to work quite well. Okay, what happened in lockdown? So in March 2020, this country went into lockdown. The university decided all teaching would be online immediately. Also, just before that, in February and March, the UCU union had industrial action with the employers. So we'd actually been on strike. And it was a kind of strike where there had been 4 weeks, and it was kind of 3 days one week, 4 days the next week, 3 days, that sort of thing. So we missed some classes in this period. They handed in the second coursework while this was happening. But the briefing on the individual project did happen. That was one of the days that wasn't a strike day. So then 16th March, teaching went online. And at that point, all the remaining classes were for the students to work on their individual projects and ask questions as they were needed. Okay. So what did I do? I cancelled all the classes because I didn't really see any point in making students do their programming while sat on a Zoom room or something, just so that they might occasionally ask me a question. What I did instead was I said, you know, good luck to you, get on with it. Please try and do it, you know, the right amount of work each week. But send me questions, email me questions. If you need to talk, we can arrange a little video call. That's absolutely, I didn't really pay attention to when the classes were supposed to be. I just said, let's just arrange something whenever's convenient. So if they needed to talk something through with me, they had that opportunity, but they could also just email, odd questions. The project progress updates, I changed them to be email updates, because meeting all of 20 odd students for 5 minutes each was just going to be a logistical problem. And I thought, well, I just need you to answer these 3 questions by email. That'll be fine. And I also wrote some extra notes specifically, or particularly, I should say, how to install Python at home and the relevant packages that you might need on whichever operating system you're on. Okay. So my experience was I spent a lot of time answering emails. I mean, a lot of time, but I had 2 hours a week of class time that I wasn't delivering. So I didn't mind the fact that I was spending a lot of time answering emails. Only a couple of students asked for video calls. They went fine. I also had a couple of final year project students who were doing quite computational or programming projects. And for all of them, what happened was we had a little call on here or on Google Meet, I think it might have been, and they would share their screen and show me something running and it doesn't run, and I help them tweak, what sort of problem you're having or what have you. And that seemed to work perfectly well. Most email progress reports, I spent a lot of time chasing up the people who didn't, because of course that's a sign that perhaps they've disengaged, perhaps they've gone into a panic mode or whatever. So there was a lot of that. Lots of students got extensions for the coursework, understandably, but broadly everything went well. I think the students did the work well, the module concluded without incident, the marks weren't particularly different to the previous year, etc. So, fine. So then we come to what on earth am I going to do next week? So this is our induction week. My colleagues who are involved with that sort of thing are currently running around in a panic, trying to run lots of different sessions for students who've just arrived. And my busy starts on Monday when we start teaching. Teaching is going to be online. There's a little bit of in-person, but it's not for this module. The problem this time is it's not just like last time. This time it's the taught section too. It's not the individual project where I'm happy to just sort of support them gently as they get on with it, but it's right from the start. The taught period is going to be like this. And this is a problem because you will remember from an earlier slide that I don't do a lot of direct delivery. I let them work on from the notes that I've written, and I drift around nudging and giving help and answering questions where it's needed and things like that. Very hard to replicate that in a online environment. So first of all, notes. Previously, my notes are sort of just pages that I've written. I've started using for lots of different things this system called Course Builder, which some guys at Newcastle have built. This is seems to be a very good system. It eats either LaTeX or Markdown, and it spits out accessible notes, which are HTML with MathJax for the maths, with a PDF version available, but it's the HTML version that's being sold as the sold to the students as the accessible version. And I like this a lot, mostly because I haven't come across much that's very good for turning LaTeX into something accessible. So I'm doing this for various of my modules. And anyway, so this is the sort of thing. This is a Markdown file. The thing on the left is the HTML output. The thing on the right is the PDF output that it produces, which is, it's a perfectly nice little Markdown compiler. And then this is a LaTeX file. So one of my propositional logic reminder sheets. And again, it's HTML on the left, PDF on the right. It seems like a nice system. So I've sort of got the notes, sorted, or I know what I'm doing with them. In terms of the classes, I don't think live online classes are particularly valuable for me for this topic. I've only got a dozen students. I could do live coding and they could watch me. I'm conscious that that was exactly what a previous speaker was going to do. I sort of think they need to be getting on with it. And I have these notes that I've written that are quite sort of in depth and walk them through what I think they need to know. There are live online classes scheduled. These are on everybody's timetables, 2 hours a week. Thinking about the two aspects of what I do in class, which are answering questions and giving formative feedback on work. Well, answering questions, I mean, I can take questions by email and video call by request, just like in lockdown. That was my conclusion. Earlier today, I've just realized I tweet these notes, but I didn't rerun the the PDF. But anyway, somebody said earlier in the chat about GitHub GIS. Right, Jenna Shipton said this, and I'm thinking, there it is, it's finally appeared. So I'm thinking that maybe that's a good idea, right? So I've tried this out in between the previous talks. I sent a gist to a colleague, and he commented on it. And I'm thinking that that's not a bad system for students to be able to say, "Hi, Peter, I'm having here's my code, here's the error I'm getting," and then I can just send a little message back. That might work quite well. Anyway, not sure. Giving formative feedback on the work, I think that's going to have to be more formal. I can't just go around and look over people's shoulders and give them feedback. So what I'm going to do is I'm going to have to set a formative task each week. And my idea for that is that I'll submit it via GitHub. So I was very excited to see that one of the talks earlier was specifically about that. And I mean, it looks amazing. I'm not sure if I have the time to invest quite so much in the automation of it for 12 students, but I'm quite excited to do that, so I might give it a go. Anyway, I don't know, but my idea was that they would all each have a GitHub account and submit work through that, and then I would be able to give them feedback on their work. So my class experience is going to be, well, next week I'm going to run a class. I'm going to outline how the module works. I'm going to cover a little bit of the sort of more mathematical content. And I think I'm going to meet with each student individually, because there are only 12 of them, to check they have Python in school, check they can work with GitHub. And after that, my teaching time is going to be answering questions and giving formative feedback, just like it would be in an in-person class, but done asynchronously. And I think that's useful. I think it's also useful in lots of different ways, because I remember in the lockdown the first time, I was very keen that, you know, students might not be available at the time, although they're locked down at home. You know, I would know families who, you know, there's one laptop and there are 3 siblings arguing over it, or, you know, both parents are in Zoom meetings at work and the kid's trying to get online as well and can't, you know, and that sort of thing. So there are all sorts of reasons that somebody might not be able to come to a live class, and this is a perfect opportunity for me to say, well, all right, then don't do it in the 2 hours, do it whenever you can, or whatever it is. So I think that's the right way to go for me. I have some outstanding questions. One is, I'm wondering if I should run a Zoom room just for drop-in, because not everybody likes emails. I'm a little bit worried that that will mean that I spend 2 hours sort of, I don't know if it'll be the most effective use of my time versus writing answers to questions. I'm not really sure. I've got to think about that a bit. When do I make the formative work due is a bit of a question that I'm having. The class runs until 1 till 3, and then I have to go and pick up my boy from school. So I'm a little bit of I can't say just hand in at 3 and I'll spend the next half hour giving you feedback on it, because I'm not available. So I could do it later that day, or shall I have them submit it a day or 2 later? I just don't know. I've got to think about that as well. And I've written here, it's supposed to be how do I incorporate insert fab thing I learned from the earlier talk. So I've got a few of those written down. So I need to have a little bit of thinking. But anyway, so that's my idea for how I'm going to run mostly asynchronous programming class next time. And at that, I'll say thank you very much and ask if there are any questions.
Thank you, Peter. In the interest of timekeeping, there are several questions, but would you mind answering them in the chat?
No, that's fine. Excellent.
Eleanor, can you, I don't know if you can see you can probably see the Q&A, can't you?
I can. It's generated, your talk has generated quite a few questions.
It has.
So it'd be great to get your views on these questions, if that's at all possible.